So first we want to point out the definition of area, which is the number of 1 by 1 squares that are able to fit into a shape with no overlap. So as you can see here, I just made out a rectangle first because we want to count out the amount of squares that are able to fit. So as you can see here, we have H amount of rows and B representing this. So what we are going to go ahead and do now is just multiply the H by the B, the height by the base. So in order to prove that all the area of the triangles is 1/2 base times height, we are going to pick any base of a triangle. And because we are going to be taking any base of the triangle, really how B can be any side of the triangle is because, as you will see in just a minute here, is we are able to rotate triangles and reflect that. More so, B can be on a different side once we rotate a triangle and reflect it the opposite way, as you'll kind of see coming up here. And now getting back to the vertexes, we have a chance of the 3 vertexes either on the triangle, inside the triangle, or outside of the triangle. So what we want to do first here is prove that the area of the triangle with the vertex on the triangle is 1/2 base times height, which will look like this, but we will go more into that. So by taking a closer look at this here, by being able to prove the area of the triangle with the vertex on the triangle, we first want to make it into a rectangle here by moving this actually to mirror. So what we want to do is actually move this over here. In order to find the area here of this rectangle, we are able to do base times height. But since we want to find the area of the triangle, actually we're able to notice that it's only half of this rectangle, and that's when we're able to add in our 1/2 here, giving us 1/2 base times height. So now here we are going to make this triangle into a rectangle, and as you can see, I already did that by adding in this here and this here. So what we did was we added these triangles to each side in order to make that a rectangle. So we have the height here displayed right here and the base that goes along the bottom here. And why do we want to show that this is 1/2 base times height? Well, as you can see, the triangles that we added is half of this rectangle. So we noticed that the height never changed, the base never changed. All we added here was this and this here. And the height and the base are still the same. So now what we want to do, so what we're able to do here now is add in the base times height, because each of those never changed, and then what we added in here was half of that rectangle there that we added. So then that's where the 1/2 comes into play, because this here is half of the rectangle. So then that's how we get our 1/2 base times height. So here we have our last and final vertex of what we're going to talk about. So here, as you can see, the height is actually outside of the triangle. And down here, as you can see, we have an extended base, labeling that big B. So we have big B minus little b and just B over here. But what we wanted to do was label that big B. Just call it a different name. It doesn't have to be big B. And so with all of these labels, the area of our new triangle is going to be up here, as I put 1/2 base times our height, because we labeled that big B. So 1/2 big B times height. So though that would be trying to find the area of the whole triangle, if that's our final formula. However, let me take a different marker. What we're actually trying to do is just finding the area of this triangle right here. So in order to find the area of this triangle, we would need to add on to this formula. And so in order to find this area of the triangle, we want to add on to our formula here and take 1/2 base times height minus 1/2 big B minus little b times that by the height. And in order to find that, we are going to distribute. And here we end up with 1/2 base times height minus 1/2 big B times height minus 1/2 base times height. And as you can see, we are then just left with 1/2 base times height, because those two cancel out. So our answer here would be that 1/2 base times height.